got a question? Yes?
Wait, are we just teaching like how to divide the items? Do the students already know how to divide? Is that what you're asking?
We're trying to get students to make sense of the rules when you're dividing integers.
Okay, so they already know divisions.
They know what division is, but they'll know this problem, and this problem, and this problem, and this problem, won't they? Won't they know that? Anybody have a question about this?
How do we explain to them like why you can't divide by 0?
Oh. What you're saying is she left off, right?
Because you know they're going to ask.
Well, and if this pattern is a pattern, this one shouldn't be left off, right? So, what's happening over here? This is, we can predict what's going here. 4, 3, 2, 1, that should be 0, right? Negative 1, negative 2. But what's happening over here? Is there a pattern going on here? 3, 4, 6, 12, and who knows what this is, right? We know, right? What is it? 12 divided by 0? We'll go over this on class Friday. It's undefined. Is there a pattern going on here in the right-hand column? No. So this may not help them, because I don't know that they're going to be able to answer that question or these questions if they haven't had some kind of other... Does everybody follow what I'm saying? Does that mean you can't use number patterns for division? Did you get one that worked?
Possibly.
You want to put it on the board here? The pattern works really nice on this side, except for this 0 one, but there's nothing here that will really help them. If I were to start this and come down to here and ask what's next, what would a student do?
16.
8 divided by what? What would they put next?
8 divided by 0 equals 16.
What's happening to these numbers?
Yeah.
Half of this is half of that, this is half of that, so a half would be what they would put, wouldn't they, next? And if this is what? Doubling, I believe that they would say this is going to be a half, and this will have to be what? 16. And this will be a fourth, because it's half of that, and this will be 32, etc. Which doesn't get us to the sign problem, if we're going to keep the pattern going. Anybody else have one? What about this one? Let's see if there's patterns, and let's see if it helps us with the integer problem. what if I took, is that the known? What goes next, class? 3 divided by 3 equals 1. How did you know that it was 3 divided by 3? Going down by 3, down by 3, down by 3. This stays the same, this stays the same. And what's happening here? Let's keep going. 0 divided by 3 is 0. What's next? Negative 3 divided by 3 is negative. Well, how do you know it's negative 1? Because this one's going down 1. Negative 6 divided by 3 is negative 2. That could possibly be used, right? You got to be careful though, or you'll end up with something that's either not a pattern or not using integers. And then you would say, when do I get negative quotients? What produces negative quotients? When I've got a negative divided by a positive. In fact, it looks the very same except the answer, in other words, I ignore the signs divide and then put, they'll start to develop that. The very best thing, I think, to teach integer division, the very best, is even better than number patterns, is fact families. If they have learned the multiplication rules and made sense of those through hot-cold cubes, through mail time, through some other means, if they've made sense of the multiplication rules, then what I think is the way to go is to go with a fact family. So I have the problem here, negative 12 divided by 3 equals blank, and I don't know what it is because I haven't learned the division rules. Not a problem. I just convert this into a fact family member that's multiplication. What is it? Help me. 3 times what equals negative 12. Now I've learned the multiplication rules, so what should I put in here? I've got to put a 4 to get the 12, and I've got to have a negative 4 because I've put together the rules that if I'm putting in 3 bunches of something, I get the temperature change of going down 12. Well, they've got to be cold cubes, right? And then, so they take that and convert it into the fact family, and they look at, well, if this problem has an answer of negative 4, what does this have? Negative 4, because they're in the same member of the fact family. Does that make sense? And so you do that with several problems. Let's do another one. Negative 12 divided by negative 3 equals blank. I don't know what it is. Write the problem. Negative 3 times blank equals negative 12, right? Well, what's going to go in the blank? A 4. If I remove 3 bunches of something, the temperature goes down 12. Well, they've got to be 4 hot cubes in each bunch. Does that make sense? So, and then you start looking at these problems, and it's, well, it looks to me like when one of the factors is negative and the other is positive, my product is, excuse me, when, if this one's 4, when one of my, when one of these is negative and one's positive, I get a negative, but when one is negative and the other's negative, I get a positive answer. And they can draw that conclusion based on what they know about multiplication and fact families. You just give them lots and lots of examples of it. All right. Multiplying decimals. How would you do it? How would you make sense of it for students? Multiplying decimals.
You can use the base 10 blocks.
Base 10 blocks. So here's a problem right here. 1.3 times 2.4. What would you do?
Well, you can have like the bars or rods, I don't know, be. Okay, let me think about it. So, I don't know what they're called.
Rods?
No, the bigger ones.
The flats?
Okay, flats. You can have the flats be the unit.
Okay.
And so you can have, like, for the 1.3, you can have one flat and then like 3 rods. Oh, never mind. I don't know how you're gonna do that. Like,
Which model are you thinking of using?
I don't know what you're asking.
There's the array model, the area model,
Oh.
there's the repeated addition, that's what I'm talking about.
Area maybe?
Well, if you do the repeated addition model, I'm going to take 1 and 1.3, here it is, and I'm going to make what? 2.4 piles of that. Well, there's 2, right? Now how do I make 0.4 of those piles? That could be a little bit difficult, but that would be the answer, wouldn't it?
Yeah.
I mean, you could do it. You just got to be able to cut. So here's an entire third group of 1.3, but I only want 4/10 of it. Well, cutting it in half would be 5/10. So, you see what I'm saying? It's a little bit harder to do that way when it comes to these decimals. Anybody else have another idea?
I can't remember what the one is called, but what if you just do like, you have the same, like, not the same system, but you have the flat and then the bars on top of it, and then it's multiplied and like, it's shaped like an L, and then, so then you have your flat and your 4 bars, this time on this side, and then you fill in.
Shaped like an L.
That's the area.
Oh, that's the
It's the
area.
area.
Oh, okay.
Yes.
All right. But we don't want to use the flat as the
As the whole.
unit this
Probably
time.
bars.
Use the bar, use the rod. So the 1 is 1 and 3, right? This is my whole, these are my tenths. Here's my 2 bars and 4/10, right?
Yeah.
Okay. What's the problem here? Or is there a problem? See, this is 1 rod times 1 rod, and I get a flat, but what's a flat? Do you follow it? If this is 1 hole and this is 2 holes, a flat, because when we do the answer, if we were to go 2.4 times 1.3, 12, that'd be 7, right? 4, 2. Did I do it right, or did I make a mistake here? 3.12 is, I mean, what's this? If this is 1, what's that? Starts to break down a bit, doesn't it? Yeah?
I know, right? Well, on the homework homework, it did distributive properties with the decimals.
Okay.
But I had never seen that before, so I was a little confused.
We can do area model, but not concretely with the. We can do it this way. We can say this is 2.4, and so out here is the 2, and there's the 0.4. So here's the 2, and here's the 1, and here's the 0.3. So 1 plus 0.3 is 1. Now, what's 2 times 1? 2. What's 1 times 0.4? 0.4. What's 2 times 0.3? 0.6. And now what is 0.3 times 0.4? 0.12. But using the blocks is difficult. But this will work. Now what do? Add it all together, right? Because this whole rectangle is our area we want. So we've got 2 plus 0.4 plus 0.6 plus 0.12 gives us 3.12, which is, right? And you mentioned that the distributive property, so we can go from the area model to this is the same as 1 plus 0.3 times 2 plus 0.4, which we then what? 2 plus 0.4 plus 0.6 plus 0.12. And now it's looking just like our area model, right? When we distribute property or FOIL it. Then what can we do you think, next? Instructional algorithm. It's just like we did with whole numbers, except we're not going to use the blocks because it doesn't make sense. So, what do? We take 1.3 times 2.4 and we start on the left. 2 times 1 is 2.000. We can put as many zeros as we want. 2 times 0.3 is 0.6. 0.4 times 1 is 0.4, and 0.4 times 0.3 is 0.12, and then we add those up. Everybody see how they're like the distributive property horizontally? And it's like our area model where we have different subsections of the big rectangle, and each subsection is one of our partial products on our, okay? What time does this class end? 15 after? Okay. So we still have the concrete to abstract going on, but we're missing the block piece this time. Because 1 rod times 2 rods is 2 flats, and 2 flats doesn't make sense in this. But just saying I've got a 1 by 2, and so here's a 2, and so on, I think is okay. It breaks it up into these parts, which questions about the decimals. So at the beginning of the unit, when we handed you out this sheet, one of the questions was, what is this? What is this? And what is this? These are all divisions. And then it says, explain why that is the case so a 4th grader could understand. Does anybody have the answers? If not, the explanation? Our former prophet, John Taylor, said this: "It is true intelligence for a man to take a subject that is mysterious and great in itself and unfold and simplify it so a child can understand it." Let me read that again. It is true intelligence for a man, or we could say a woman, to take a subject that is mysterious and great in itself and to unfold and simplify it so that a child can understand it. So, can you explain the answers you get to these, why they are what they are, so that a fourth grader would understand it? Not so that a fourth grader could memorize it to write the answer. Well, we will answer that question on Friday, so I hope you're all here.